Sampling and modeling. So let's say the data is given to you and you want to use the formula. Okay, so the formula to find sampling mean and sample standard deviation. For sampling mean, you have to add all of the data divided by the number. This is the data we have, right? Percentage of return. So add everything here divided by the number of them, which is 20. Standard deviation sampling is the square root of x power 2. So add x power minus n multiplied by x power 2 divided by n minus 1. So addition of x power 2 means you have to power to each of these numbers first, and then add them up after you square them, right? It'll give you this. And minus n multiplied by x power. So you have an x power, you have a mean power 2 and divided by n minus 1. The thing is that why we do the sampling, because the population is very huge. So we cannot ask, let's say you want to interview everyone in a country, you cannot ask everyone in a country. But, some projects, right? So you have to make a sample. Let's say you go to a school and select few people rather than asking the whole entire schools. So you sample. For the sampling, we have a different methods to calculate. So here for standard, this is the equation for standard deviation. And when you put the x bar on the top of x on the top of the bar on the top of x, it means mean, sampling mean. Sampling. And here is the standard sample standard deviation. So we got the sample standard deviation and the mean. Now, the question said, assume that data are normally zero. What is the probability that the annual return will be at least 9%? So at least 9% means you need to find a z-score for of 9. When the x is 9, we have x bar, the mean value from the previous step, divided by standard deviation. The z is negative 0.36. And you say at least, maybe I just make a picture here. This is distribution, this is your mean. Got the mean to be 12.4. And I want it to be at least 9. Then 9 going to be on the left side. At least 9 is 9 above, right? I need to find this area. That's why we turn this one to the z-score, which is negative 0.36. And you want to find when the p is greater than negative 0.36. Just remind you, you go here, negative 0.36. If you do that, you get the area below that. So to get an area be above, we just say 1 minus that area. This is first area here is negative 0.36. 0.3 and 6 here will be that number. 0.3594. So 1 minus that will be the area above. See, 1 minus 0.3594 is that 0.64 or 64%. Negative. So doing annual return will be negative. So it means x should be less than 0. First, we need to find the scores. The score is 0 minus 12.4, 9.49. Standard deviation. So it is negative 1.31. Just looking at that, negative 1.31 -1.30. What was that? -1.31. Okay, this is going to be 0.095. We'll give you do that. Let's say here is my 0, right? I want to find this area. We convert this into z-score, and we got the z-score to be, where 0 to z-score is -1.31. I want to find the area here. We'll go to -1.31, so it's going to be this number, 0.095 or 9.5%. Let's just look at the answer. 0.095 or approximately 9.5% or 10%. Okay, part C says, out of the next 10 years, how many years would ERN expect to show returns greater than 6%? So greater than 6% means if the 6 is here, 6 is here, I want to find the area above 6%. So just turn again 6% to z-score. So it's x greater than 6. Now I want to do z to be greater than what? So just I turn 6 into z. 6 minus 12.4 divided by 9.5. So again, I'm because the area will give me the area less than that number, right? I need to say 1 minus p of z less than 0.674. I just find that from the table, which is -0.25. Check that from the table. It's equal to 0.75. So when we have a normal model for discrete data, we have to be careful how do we use this score things. You get this question: a company products box of candy-coated chocolate pieces. The number of the pieces in each box is assumed to be normally distributed with the mean. So we have a mean. X bar is equal to 48. My standard deviation S is equal to 4.2. Okay. Quality control will reject any boxes fewer than 44 and the boxes above 44. The result makes this class 2 company. What's the probability that the box selected random contains exactly 50 pieces? So I'm just putting that picture here. In the middle, x is equal to x bar plus 48. Now 50 is above that, right? So here is, let's say this is the 50. I want to see exactly 50, so it means, because this is discrete, I have to say between, I need to find area between 49.5 and 50.5. So I put a half above and below. I want to find the probability when the x is between 50.5 and 49.5. So what you do, you just convert each of these numbers to z-score, right? So this one to the z-score going to be x minus x bar. So it's 49 minus 45 divided by standard deviation, which is 4.3. So now I convert it to the z. So I put the z in the middle. And here is 50.5 minus 45 divided by 4.3. I know if you want to look at it, let's just look at this numbers. See what was it here if you calculate that. So this is 0.35, 0.58. Here P 0.35, and here is that one is 0.58. Things for the zeta score, I just want everyone to be careful when we do this. The zeta score, this zeta score is give you the area below that number, right? But right now I have two numbers. I want to find the area between two numbers. Like from here is Z1 and Z2, right? I can't find the area below Z2. The whole area of Z below Z2 is that, right? And I can minus it from the area below Z1. And it will give me the middle area between them. So we do the same thing in this. We say that if you want to find it, the area between 0.35 to 0.58, you just take an area below 0.58 and minus it to the area below 0.35. You get the trapped area between these two numbers. So going to that Z square area less than 0.58, I can go to 0.5 and 0.58 will be here. 0.719, as you see, 0.719, and area less than 0.35. 30 is here, 5 is here, 0.6368. 0.6368. So you minus there, this two will give you 0.08. This will be a trapped area between. So the trapped area is going to be 0.082 or 8.2%. Now, you want to see what percent of their population will rejected by quality control as contain too few pieces. So again, if you just make a shape here, in the middle, we had 48. That was X bar. Few pieces is cannot have less than 44, right? So 44 is your maximum there. But less than that, so it's going to be 43.5. We don't put, because 44 is acceptable, right? You have to put a lot less than that. And you need to find this area which is rejected. Less than that is not acceptable. Again, you can find the, want to find the probability that X is less than 43.5. You convert this one to the Z score. So Z less than, so converting to that's going to be X minus mu, which is 48, divided by standard deviation, which is 4.3. So you get P Z less than, let me just look at the number for part B, is negative 1.05. Negative 1.05. Then you go to the table here again. Negative 1.0 is here. 5 is there. 0.1469. 0.1469. They rounded to this 0.1, which is approximately 14.7%. Okay. The other part C, is that each filling machine produces that much boxes per shift. How many of this lie within the acceptable range? I just want to find the probability for acceptable range, which is 44 to 55, right? But actually, the acceptable range is 43, between 43.5 and 55.5. Have to use, because you want to include this and you want to include this, right? The actual range is that, so X should be between. You need to find a probability that X is between these two numbers. So as we've done before, for part C, so that you convert each of this number to this z score, then that should be between negative 1.05 to 1.51. You know the area below 1.55 minus the area below that will give you the answer, the trapped area between these two. So PZ less than that minus PZ less than that. So again, you go to the table, find that probability. Sure, we can find it. Go to the table, find that probability minus each other. That would be this. But this is the probability of finding acceptable range. We have produced 130,000 boxes. So multiply it by that probability, that will be acceptable, means just 10,000 of that will be acceptable. Means too many of these chocolates or boxes will be not acceptable, right? That's why you have to revise. So they need to revise the packaging process. So for this, please do the even questions and submit your answer to teacher.